In this video, we're going to look at the inverse trig functions, inverse sine, inverse cosine, and inverse tan. So we'll start with inverse sine. A couple things I want to remember is that we talked in chapter 1 about the definition of inverse means to switch x and y. And then also this graph that we're looking at here is the graph of y equals sine x, no transformation, just the basic sine graph function. So what we have here is a point A, and as we move that point along this function, you can see the coordinates of point A up here. What we can also see over here is point B, which is the x and y coordinates switch, so point B is the inverse point of point A. So if we move this along the graph here, we can start to see those inverse points plot out. So if I animate that point, we can see that sort of move a little bit quicker. So what we can see from this graph is that the red dots are creating the graph of y equals sine inverse of x. Hopefully what you would notice from this is that this is not a function because it would not pass a vertical line test. So what we do is we just take a small piece of this graph to be the function y equals inverse sine of x. So here you can see the piece of the graph that we take to represent the inverse sine function. What you need to notice is that your domain goes from -1 to +1 and your range goes from -π/2 to +π/2. So it's just a very small piece of that graph. So when you are using your calculator and you're doing an inverse sine calculation, you will notice that your range is between -π/2 and +π/2, or if you're working in degrees, that's going to be between -90 degrees and +90 degrees. If we translate that range value to the circle, we can go from -π/2 to the +π/2, and then we're going this way, so we're going to hit the 0 and then come up here to the +π/2. So when I'm calculating an inverse sine using the circle, I can only use quadrants 1 and 4 because that's what coordinates with my range for inverse sine. Also, we need to be careful in quadrant 4. When we're down here in quadrant 4, we need to be using these negative rotations. You could use the degree or the radian values, but typically you're going to use the radian values, so I'm just going to circle those and highlight those. Also here we can only use 0. We can't use the 2 pi or the 360 degrees, because if we kind of translate this to a number line, this would be -2 pi, this would be 0, this would be 2 pi. My range goes from -π/2 to +π/2. So this value's right in this section here, and 2 pi is not included in that, but 0 is. Also down here, same with these negative values. So -π/6 would be in the yellow region, but 11π/6 would be way out here at close to 2 pi. So we have to be careful in quadrant 4 that we're using the appropriate values. So if we look at a couple examples here, when I'm doing inverse sine of 1/2, we're giving an exact radian value, so we're going to use the unit circle. So when we're doing inverse sine, we're just going in the reverse order of what we were doing before. Previously, I would have said give us the sine of π/6. So you would go to π/6 and then give me the y coordinate. Here, I have to remember that if I'm doing inverse, I'm giving you the coordinate or the ratio value, and you're going to give me the angle of rotation. Notice the directions ask for radian values. So what we want to remember is when we're doing inverse sine, I'm thinking that I want a y coordinate. So basically this is saying where's the y coordinate equal to 1/2. Well, if I look around my circle, my y coordinate's 1/2 here and my y coordinate's 1/2 here. But then I have to remember what we talked about before. When I'm doing inverse sine, I can only use this region. So I don't want to consider this point over here at 5π/6 at all. I only want to consider this point right here. Since they asked for the value in radians, I'm going to give the answer of π/6. So then again, here I'm looking at where is my sine value 0. So remember, I can only look over here in the shaded region. My sine value is 0 right here. And then again, remember at this point, I want to use the 0 and not the 2 pi. So here my answer would be 0. A couple more examples over on this one. Remember, this is the region that we can use. So this one says I want to do inverse sine of negative radical 2/2. So I'm going to look for where is my y coordinate negative radical 2/2, and that happens here. So remember, I want to use the -π/4 and not the 7π/4 because of my range. So -π/4. And then finally, I have inverse sine of -1. So my sine value, my y coordinate is -1 right here. And again, I'm going to use this -π/4. negative pi over 2. One thing to notice here on these two examples, notice your arguments were negative and your answers were negative. So here my argument was positive and my answer was positive. Here my argument was 0 and my answer was 0. So with this sign, when you're doing inverse sign calculations, your argument will have the same sign as your answer. Okay, so now if we work similarly with cosine, so here we have the graph of cosine of x. Again, the green point is a point along the cosine graph, and the red point is going to be that inverse point. We animate that point, and we get the red dots here showing us essentially the graph of inverse cosine. Again, we have the problem that it's not going to be a function because it's going to fail the vertical line test. So we, again, just take a small piece of it, and that piece is going to go from the x-axis up to here to where it starts to turn again. So we come back here, we can see the inverse cosine graph, again, coming from 0 up to pi. So my range goes from 0 to pi, and then along the x-axis, my domain values are going from -1 to +1. If we translate this range from 0 to pi on the circle, here's 0, we're going to go over here to pi. So when we're doing inverse cosine evaluating, we're going to use quadrants 1 and quadrants 2. So with inverse sine, we were using quadrants 1 and 4. With inverse cosine, we're going to use quadrants 1 and 2. So again, taking a look at some examples, the first thing we want to think when we see inverse cosine is this means x value. And so I'm looking for where my x value is 1/2. So my x value is 1/2 here and also down here. But then if we remember that when I'm doing an inverse cosine value, I can only use these two quadrants up here. So we have to ignore the 1 at the bottom because it's not part of my range. And this is the point that I want to use. Again, the directions ask for radian values. So we're going to say pi over 3. So on the second example, we're doing where is the inverse cosine -1? Well, that actually only happens here. So I'm using this point. Again, we wanted radian values, so we're going to go with pi. Two more examples here. We've got inverse cosine of negative radical 3 over 2. So I'm looking where my x-coordinate is negative radical 3 over 2. So that happens here. Remember, it also happens down here, but that's not part of my inverse cosine range. So remember, these are the quadrants I'm using. So I'm going to use this point here. Radian value is 5 pi over 6. And then my last example here is inverse cosine of radical 2 over 2, and that's happening right here. And again, my radian value there is going to be pi over 4. Finally, we're going to look at inverse tangent of x here. I went ahead and did the animation because it takes a really long time. So as you can see, the purple graph is our tangent graph. The red dots are representing our inverse tangent. This graph gets quite busy. So again, though, what we should see is that the inverse graph represented by the red dots is showing us a graph that is not a function because it won't pass the vertical line test again. So again, we just take one part of this, and the part is actually this little piece that goes through the origin here, and we ignore all the other pieces. So again, if we come back here, our inverse tangent graph is this piece that's going through the origin. This graph is slightly different than the other graphs because it does go left and right forever. So my domain is negative infinity to positive infinity. So all numbers where my range is from negative pi over 2 to positive pi over 2, and those are asymptotes, so they're not included. So if we wrote that in interval notation, we would go negative pi over 2 to positive pi over 2. And again, in degree mode, that would be 90 degrees, negative 90 degrees to 90 degrees. So again, just like with inverse sine, I'm going from negative pi over 2 up here to positive pi over 2. So I'm using quadrants 1 and quadrants 4. And again, we want to be careful in quadrant 4 that we're using the appropriate values, which is those negative values, and not the 360 and the 2 pi, not the 330 and 11 pi over 6, etc. All right, so looking at some examples here, remember when we're doing tangent, tangent is your y value over your x value. So I went ahead and added those values onto your circle. Remember, for your tests and exams, you're going to get this circle, but the tangent values will not be on there, so you will have to be able to evaluate them by dividing, or you can memorize them, whatever you want to do, but you'll need to know those. So on this first one, we're doing inverse tangent of radical 3, so I'm going to look for my tangent value of radical 3, which is happening here. Again, my directions ask for radian values, so I'm going to go pi over 3. My second one, I have inverse tangent of negative radical 3 over 3, so that one's going to be down here. So again, I want the negative radian value. So remember, this is negative pi over 6. Two more examples here. We've got inverse tangent of 0. So that happens here. Remember, we want to be careful here that we give the answer of 0 and not the 2 pi. And then finally, we've got inverse tangent of negative 1, which is happening here. And so my answer is going to be negative pi over 4. Okay, so here we have some examples where we're combining the standard unit circle sine, cosine, tangent questions with the inverse sine, inverse cosine, inverse tangent type questions. So we just kind of have to combine what we did previously with what we're doing now. So on this first question, it says find the sine of inverse tangent of 1. So really we just want to work with this inside first. So first I want to do this. So inverse tangent of 1. So remember that my tangent value was 1 right here. So if I'm using this point, this is going to become, this inside value is going to become pi over 4. So I'm going to rewrite this as sine of pi over 4. And then remember, this is when we just go to the value of pi over 4, and then I want to find the sine value, which is going to be the y-coordinate. So now my answer is going to be radical 2 over 2. So if we look at the second one, we're doing inverse tangent of cosine of pi. So again, let's do this first. So cosine of pi. So here's pi. I want my cosine value, which is the x-coordinate, so negative 1. So then this becomes inverse tangent of negative 1. So always do the inside part first. Then I want to think, where's my tangent value? Negative 1. So that happens down here. So my tangent value is negative 1 at this radian value, which is negative pi over 4. So here we have sine of inverse tangent of negative 1. We're going to do the inverse tangent of negative 1 first. So again, we're here. So this becomes, what's the sine of negative pi over 4? So at this negative pi over 4 value, my sine value is the y-coordinate, so negative radical 2 over 2. And finally, some equations where they're asking us to solve for x using trig functions and their inverses. So remember that the trig function and its inverse are going to cancel each other out, essentially. So here I have inverse cosine of x equals 1. So I want to bring this cosine to the other side. In order to do that, I need to use the inverse. So then this would become cosine of x. The inverse of inverse cosine is just cosine, so cosine of x equals cosine of 1, so then we just get x equals 1. So essentially what's happening is that the inverse cosine and the cosine are canceling each other out, and I'm just left with the x equals 1.